Fungi are fascinating. They're weird and funky. They are the ultimate alchemist of this planet, and they're able to do so many great things for us. We can learn from nature to solve some of the world's biggest problems. There is no waste in nature. There's always something else that takes advantage of the byproducts.
We're trying to emulate that here at Mycocycle with mushrooms at our core. They're cleaners and they're builders.
We're able to unlock the power of fungi.
So Mycocycle is a process that trains and develops fungi to be able to treat industrial waste streams, particularly construction waste. We're able to not only detoxify waste, but to transform it into new materials in 2 weeks or less and in just 3 steps. My name is Joanne Rodriguez, and I am the founder and CEO of Mycocycle. The waste generated in the construction industry takes up space in landfills, and it can leach toxins into the air, water, and soil. 40% of all greenhouse gas emissions are generated from global construction activities.
The current methods to handle construction waste are not sufficient. We have a huge amount of this waste left over that is not being converted or not being reused. Through the use of our technology, we will speed up the conversion of these waste streams into reusable materials. My name is Daniel Reyes. I'm the technical co-founder of Mycocycle and the vice president of research and innovation. Mycoremediation is the use of fungi to neutralize and even degrade toxic constituents in nature. So every day we're on the hunt, going out into nature, looking at places like landfills, oil spills, urban centers, and finding fungi that have developed tolerance or an ability to break down and survive those conditions. So for the most part, we observe fungi through their reproductive organs, right? The mushrooms, the fruit bodies. Mycelium is underground, they're unseen. So mycelium is different from that fruit body in that the mycelium is actually the vegetative part of the fungus. It's made up of hyphae that are interwoven within one another, expanding their overall structure. In nature, mycelium are great at decomposing organic matter that are very hard to break down. And we can translate those properties into decomposing construction waste. Slowly, carefully, we teach the mycelium to eat trash by exposing little bits at a time until the mycelium has developed an affinity for these materials. So we mix our base substrate with our construction waste. The mycelium first attacks our base substrate. It kind of gives it a little bit of an energy boost. It starts to secrete this cocktail of enzymes and other metabolites. At the same time, the mycelium will make a jump from that base substrate to the construction waste, and slowly they start to break down this construction waste.
It goes into incubation for a period of 2 weeks. And then we harvest it, we stop the growth and process it to become a fiber or a fill to meet the needs of manufacturers in the raw material market. The mycelium itself has a physical property that lends itself to fire resistance, water resistance, lightweighting, and thermal insulation. It's very, very strong and can penetrate even some of the smallest structures, like in textiles. Our Mycofill G is a composite raw material from gypsum board and mycelium. It's a redless chemical-free material, and we can make mycofiber, which is a shredded version, and we can make what's called a mycofoam. Mycofiber and mycofill can go into everything that you see around you, including concrete, walls, floors, ceilings, furniture. For every ton of waste that we treat, we're able to reduce CO2 emissions by almost 3 metric tons.
The potential of waste, I think, is actually a very funny phrase. Waste is defined as pretty much it has no use, but we see it as a valuable feedstock. So in order to harness the value of waste, it's going to take reframing that term waste and the way we think about end of life. All of these materials that are going to landfill today, whether that's cellulose fibers or fiberglass or even rubber, have really interesting innate mechanical properties and physical attributes that should be given a second opportunity and a third opportunity and a fourth opportunity that can be used towards creating the materials of the future. Mycocycle is bringing that technology to unlock this.
We're looking at scale solutions in a couple of different ways. One is through our mobile bioprocessing unit that allows us to decentralize waste management. We can roll up on site, plug it in, and be ready to go. And then big picture, we're going to have large-scale facilities that could process materials into new raw bio-based applications. Globally, Mycocycle hopes to treat 1.5 million tons of waste a year within the next 5 years. It sounds kind of crazy, but when we think about all the waste that exists out in the world and all of the opportunities to create value in the new markets, we know that it's absolutely plausible. So we'll be able to take the waste at some point in time without getting paid for it. We will need the waste to create our raw materials, and we can responsibly get into these markets that present revenue opportunities and closed-loop ecosystems.
The future of construction is entirely circular. The way that we are using resources right now is a very limited version of what is possible.
The opportunities and applications of mycelium are incredibly far-reaching. I think we are really just scratching the surface.
So we have the opportunity to help nature be a value player to our economy. The world I imagine with more mycelium solutions is just cleaner and more efficient. In fact, I think mycelium is at the core of the circular bioeconomy and fights climate change with nature.